This is a video for pages 15 and 16 from the math packet for 7th grade, Understanding Graphs of Proportional Relationships. Well, when we look at this graph, okay, we see that we have a series of points on the graph, and we're trying to figure out the cost of 1 apple and 3 apples. So if I look down at this part of the graph, it says number of apples. So I'm finding 1 on the graph and trying to figure out the cost. Well, it looks like for 1, it is right in between 50 cents or zero point 0.5 and $1 or 1.0. So it looks like the cost of 1 apple is right in between the two of those, which is 75 cents. Now I want to figure out the cost of 3 apples. So I'm trying to figure out where this point is right here on the number side of the graph. Well, it looks like it's also in between two numbers. I'll give you a chance to think about it. And you were right if you said that the cost of 3 apples is $2.25. Well, what about 0, 0? It says, what does that represent in this situation? Well, I want to think about what each of these numbers represents, okay? The 0, the first 0 is the number of apples. So that means that 0 apples would cost, is the y in this case? The y, the second number, is the cost. So 0 apples would cost $0, okay? What does the 0.2 and 1.25 represent? It's the same as the one above, but now instead of 0 apples, we're looking at 2 apples. We're trying to figure out what that 1.5 represents in a real life situation. And I'll let you guys finish that problem. The second example talks about how much Manuela earns for each hour of tutoring. Hopefully you can see this graph, but the x-axis here is hours worked, and the y-axis is her earnings. We are trying to figure out how much she earns in 1 hour or each hour. Well, it looks like I can't 1 at 1, which is in between 0 and 1. It's not what I call a grid point on the graph. It doesn't cross a grid there, but it does at 2. At 2 hours, she earns $20. It does it 4 again. At 4 hours, she earns $40. So hopefully you're seeing the pattern. I could imagine what are the missing numbers here. 0, she's earned $0. I don't know for 1, but at 2, she's earned $20. It's hard to tell for 3, but at 4, she's earned $40. Well, can we go back and use our proportional reasoning to fill in these blanks? I hope so. I hope that you can see that this is going up by 10 each time. So for 1 hour, she must earn $10. For 3 hours, she must earn $30. So that means that each hour, as this goes up, we're adding 10 each time. So the constant of proportionality, the number that goes up each time, is $10. We might say in real life terms, we would talk about this as $10 per hour. That's her rate of pay. And then we want to write an equation. Well, we found the constant of proportionality, 10. That's our y. That's how much she's earned, the money she's earned. Okay, and that's going to be equal to how much she gets paid per hour. So hours is x. So you fill in the blank for that proportional relationship equation. On the second page, for interpreting graphs of proportional relationships, it continues. So for number 6, we're trying to interpret the constant of find the constant of proportionality, okay? So again, remember the constant of proportionality is how much does it change when x equals 1. So I can find the constant of proportionality on this graph by figuring out where x equals 1, okay? If I want to be sure, I can continue this table here. So if I wrote the first 3 things for this table, 0, 0, 1, and 2, okay? When x equals 1, it looks like the distance equals 50. When x equals 2, the distance equals 100. So it looks like the constant of proportionality, how much is this one going up each time? when x goes up another value is going to be 50 miles per hour. Sometimes in math, we use the letter K to represent the constant of proportionality. For the second problem, it asks us to pick and interpret just one point on the graph, okay? So if I just pick any point, like for example, let's pick this one right here. That's the point 3, 150. What do those numbers mean in real life? 3 what? 150 what? That's what I want you guys to answer that, to figure out. And then take this constant of proportionality and write it into an equation. So D is my output here, and that is going to equal what times T? That's the equation. Okay, then I want you guys to use this graph below for 9 and 10 to help figure out the cost, that whether or not these questions are correct. I think it helps to find the constant of proportionality here. So when I started this problem, I wanted to figure out what was the cost for 1 pound of chicken salad. So if I can look on this graph, it looks like 1 pound is going to equal $7.50. Once we know that, we can figure out if Randy is right. He thinks he can buy 3.5 pounds or 3.5 pounds for $23.50. Is he correct? Think about that. Draw a table, draw a number line, see if he's correct. For number 10, it wants to know how much chicken salad. Remember, the cost for 1 pound is going to stay the same. So it's still $7.50. Can you buy for $52.50? Okay, think about the answers to those. If you're not sure, you need more help, show up for tutoring on Wednesday.